Hi. So the question is, do share the details of some of the economical scalable models that can be replicated across hundreds of acres. Yeah, the interesting part is that every strategy is unique to the environment that is there, the variables that are available. If there is an existing native forest close to that region, uh, or if there isn't any, the kind of species that are available, the soil quality, but the most underlying factor is that if we're able to understand how a forest evolves, it would really help us figure out what kind of strategies to adopt for the particular site. For example, the theory that we use today. I'll run you through the theory, and I think it will really help you out if you could get some idea around it. So the theory of ecological succession has been proven to be the most interesting ways of seeing how forests evolve, and makes quite a lot of sense. If you can see over here, this is how from the scratch, if there's nothing, not even base soil, from rock, it slowly the life transforms, right? With the lichens coming in, the small annual plants coming in. So this is the pioneer stage. I think like wherever we go, normally we find sites which have at least crossed this stage of evolution, and this itself would have taken thousands of years from to reach from here till this point. So once the lichens and all have started colonizing the rocks, they start breaking down the soil slowly, and these soils are like still not really nutrient rich. They can't really absorb that much water. So the herbs, small herbs and grasses, they start growing in. So you'll see often next to the construction sites and next to, like, if somewhere a new road has been made, you'll see the weeds and the grasses are the first ones to come, even before like larger shrubs come in. And that's also one of the reasons why a lot of species like lantana have been able to colonize such a large part of India. The problem is not that they're very invasive. The problem is that our level of forest is very degraded, and these kind of species are there. These are the first healing elements of the nature. So it's the strategy. So every time the nature thinks that something has been disturbed, it sends out these weeds and the herbs. These are very small seeds. So they need to have sunlight the moment they touch the ground. They need access to direct sunlight. That's why you'll see the weeds and the grasses don't grow in very dense forest. So they'll grow, and then slowly over a few decades, they'll just grow and die in the soil. Hell, slowly, when they die, the roots will add on to the soil. The bacteria that have started coming in will start breaking down the rocks further. The roots will start breaking down the rocks further, which improves the soil quality. And when things change, once your soil is good enough, the larger species like the shrubs will start coming in next. And these shrubs their roots grow much more deeper. They can grow much more taller. They can harvest. They can sustain beyond just a season. For example, grasses mostly they'll die out when the winter comes or when the things are very dry. So they cannot keep building over what it was the last time. Every time they have to start afresh, and that's something very similar with the herbs. They can't really build up that strongly over the previous investment because they were designed to colonize new spaces where the resources were not much. So every species can only adopt one kind of evolution tactic, and then get all its access to it. So it can either adapt itself to grow in very barren land, or it can adapt itself to grow in a very dense area with a lot of good soil. It can't do everything. So as the soil and no matter how hard they try, over the time as they keep trying, the soil will become better and will provide a much more conducive environment for the shrubs to come in. And when that happens, um, you'll see the shrubs have like much more smaller fruits, which could be dispersed by the help of birds. So they're long distance travelers, the seed dispersal methods. So the moment these shrubs start taking in, they start attracting the birds, and along with the shrubs will come the pioneer species of the shade intolerant kind. So this is also something we call the early succession species, species that do not like shade, who love to grow in out in the open sun. So these are the species which grow in any kind of soil. For example, neem is one pioneer species, which you would be very familiar with. And a lot of fruit trees are like bird cherry, paya, padam. So these are all pioneer species which birds which want the seeds to go far away places and colonize open spaces wherever there's a bit of sunlight and grow over there. Uh, but over a particular period of time, because these have adapted themselves to grow in sunlight and colonize those spaces, what happens when 30 years down the line, 50 years down the line, there's just too many of them on that spot, and there's just too much shade that has been created. And that's when your climate species start stepping in. These species have adapted themselves to grow in the shade. So these are the kind of species you'll find in the most oldest of forests. These are the ones which can keep growing the shade of their own trees. These are the species which support their own young. They live like a community. So even the seeds for them would be much larger, and in many cases not even edible by animals to that extent. So when the seeds will drop, they usually drop the seeds, at least not by the birds. You see mostly they're not edible by the birds. So when they drop their seeds, they drop it very close to the parent tree, so it could grow in the shade of the parent tree, where in the absence of sunlight, the parent tree itself will feed it with the nutrients. So these kind of strategies allow the trees to be to grow in very shade kind of thing. And these are the forests which are the climax forests, which you would have seen were formed major part of India and the rest of the world till the human intervention on large scale deforestation started happening, right? So now we that also mean that because these climatic species they grow in shades and in very good amount of soil quality has to be quite good enough. So they find it very hard to spring back into action in places which are heavily degraded, either through farming or land abuse or like a very high intensity fire. So what happens is that this is a dynamic process. Like you won't see if the entire world would have converted to climate species, then we would not have had any species of pioneers or the shrubs left. But the forests keep changing, and it keep moving between this forward, back, forward, back, forward. Um, so yeah, if you want this, this is how it works, right? So if we understand how a forest really evolves, it makes it much more easier for us to um, really plan a strategy. So this is not a case that you'll find these days. The most common case you'll find these days is the secondary succession, where the forest that was originally there um, has been destroyed either because of fire or because of large scale deforestation by human activities. In these cases, because the layer is already there, you can see the difference between this one and the last one was that the last one, the soil builds up over the time gradually. Here, the soil is already there. So because there was this, for example, there was an old forest over there which has completely destroyed, either being clear cut for farm use. Here, it happens much more faster, the same succession. The annual plants start coming in, the weeds, which we call. So these are always the first colonizer of the land, and the grass and the perennials they start coming in 3 4 years of time. The shrubs and pioneer species they start coming in over the next 5 to 150 years, and then like around 200 years down the line, you'll find your climax species slowly coming in. So when people say that, when they say that isolating a piece of land is the best and the most economical strategy, I agree with them in cases where there are existing climax forests around, because climax forests, the seeds of these trees, they don't really propagate that far. They usually drop it much closer. So if we just leave a patch of land, untouched, just enclose it and keep it, it will start moving up on the succession, like towards a more matured form of forest. um, but it would be restricted by the kind of species that are available. So in kind of in strategies where we have existing old forests around it, just um, just close off, cordon off the spaces. So that comes under your accelerator regeneration strategy. If you have if you have places where there are no climax community, or even the pioneer species are not really large in numbers, there's not much diversity. For example, extensive farmlands where, like for example, UP has just 3% of the forest left of the entire landscape. So even there, if somebody leaves their farmland barren, it takes a very, very, very long time for even the for even the shrubs and pioneer species to start coming in, because there's no seed bank anywhere. So in those kind of cases, my Miyawaki forest helps create those little seed banks, which would then help regeneration of the entire region. So then you'll use it in conjunction with other strategies to facilitate the regeneration. In cases, and then if you have existing forests, then another strategy which is quite good is the framework species method, where you identify certain species which help building up the soil really well, building up nitrogen and all the other organic life form which grow very fast, and then you plant them. And then what happens, it creates a kind of a pull. um, uh, it will, like, you plant mostly like fruit bearing species. So when the birds are flying in from different places, they are bringing in more seeds and introducing more species. So if you have climax community and pioneer, if you have these seed banks somewhere close by, then you can get into the species framework method, which will help you with much more low cost, help expand the forest much faster with the pull strategy. um, we will look how these things work on a larger scale. Let's see. Okay, so this is, for example, for me, a site. This is a if you understand contour lines, it's great. Basically, it says that these are like the high points um, of the site. Um, yeah, a little bit high points here and there, um, but it's sloping downwards through this, and every kind of land has some kind of gradient. Some has gentler, some has larger. So these slopes also and help us understand and plan better if you're looking at one large site for reforestation. So in this case, what I would do is that I would probably um, I'll do certain planting around this region, this ring, with along with water conservation structures. So I'll treat a Miyawaki forest in this little patch over here, this little patch. Because if I go around doing Miyawaki forest everywhere, it's a waste of resources. Doesn't justify the cost, especially the saplings. It takes a lot of issues, and if your land is does not have an issue, does not have a history of aggressive machinery use, then even the soil work is not much of an issue. Then your cost drastically comes down. If your soil has compaction, then you'll have to like either introduce a 20 centimeter soil, or like till the soil a little, which you can even do if an agrarian kind of space where the compaction is not much, then you can even do tilling by bullocks, which is very simple. So there are very economical methods of implementing the Miyawaki method in these cases. And these will, like, small patches for me will become the seed banks. So once these seed banks have been established, what I would do is then I would use my species framework to plant certain fruit bearing pioneer species and certain bird attracted climax species, and plant them over everywhere, like slowly in different patches. So these are much more like pit method of planting, but not that many. I don't want to like completely plant the entire place, but for them to enough to start, if they grow up and start providing shelter for the birds, Then they'll start pulling in the genetic resources from the Miyawaki forest, which already has like over 50, for example, a number of species out there with their fruits. So what will happen is that now this was a seed bank, and now you're using the forces of nature to pull them into different direction and make sure they spread out much faster, right? So a lot of time when we look into the idea of reforestation, we're limiting ourselves to one method versus the other, or we are limited ourselves by all what the humans can do. But I think it's much more efficient if we could understand the flow of nature and use those natural forces to really increase the efficiency of our projects. So then these will start flowing out, and once we see that certain regions um, have enough, at least 70% of, even at least 50% of canopy has been created over there because of the seeds, then we can get into the direct seeding method as the last stage. And direct seeding, it doesn't work if you are, so direct seeding has its own challenges. For example, it doesn't work for every species because the seeds are not all, do not stay viable for a long time after being harvested. They have to be instantly, a lot of seed species have to instantly find root. Then it's actually very hard to go out and collect seeds of the native species itself, and that too in that number. But where direct seeding really works well is that once if you have canopy that is like a tree shape created on the top, you can get the seeds of the late successional species, as we talked about, the climax species of the trees, and then spread them and scatter them between those shaded areas, because the climax species have like much larger seeds and much larger food bank inside them, so the chances of germinating is much more higher. So when you go for a mixed strategy, it really helps in those circumstances. And this would also change by your clientele. For example, if you are working in an urban scenario, then it's best to have Miyawaki forest because you need those concentrated places, spaces to grow the forest. You don't have that much available space, and I know, and they act as a seed bank, right? So if you have multiple plantation like this around a city, for example, this would have been city map. From there, you would try to see how you can um, pull the birds and the animal flow to further propagate things. If you're thinking about the rural side, what you can do is that you can have for a large area, you can have one Miyawaki forest, and then you can incentivize the farmers around to leave certain patches of land, like at least the edges, the borders of their land. Um, I'll show you that like this. Yeah. So in case if you're working the farmers, you can say that if this is the farm, if they could, just give the edges over here, what you can do is you can get into the direct seeding method with them, where you use their own tillers, like how they sow crops, pulses and all. So what you can do is you can mix the leguminous seeds with some of the herbs, um, like green mulching material, and some of the shrubs and the pioneers. Like just mix some of the very viable seeds and all together, and then through their tractor they can plant this edge. So what will happen is that they'll get crop of pulses and corn, whatever maize they have planted along with it, and it would have added a lot of nitrogen into the soil, which would help the shrubs and the pioneer species seeds, which have also gone along with the same seeding material, to start slowly germinating, and over the time they'll take over. So once they have taken over, then after a period of 2 years, they can introduce the species of late succession species. They can just like throw the seeds over there, and they'll start growing. This way, a farmer can, with very small amount of resources, generate a sort of forest fencing around his patch of land, which block the the farm which would block the loo, the wave, which usually um, um, is a danger to crop. It would also create microclimate for the crops to grow better. It would also provide pest control spaces because the vegetarian insects that grow on the leaves of the plant. They eat the leaves, so that's where they grow. But the predator insects, they grow. They live and survive on the forest floor, on the soil floor. So they need a sheltered environment. If the land is exposed to the sun, they can't stay there, which is how the traditional farming practices, like the modern farming practices, do. They keep the land open. So if they could find the shelter spaces in these things, they can your predator insects can move in times of pest attack, deal with the pest and then move back into their homes. And they also like help pull up the water levels. They help lower the temperature, evaporation. They help build up some of the fungi networks and the kind of things. So farmer can really benefit from these things without using the resources the farmer has, and you can probably even have his own lumber species. So yeah, I think it's a mixed strategy based upon like the fundamentals are the same. The idea is to tap into as much of natural flow of seeds as you can tap into, because also the seed germinated like plants are much more strongly anchored in the soil. Um, um, yeah, that's all. Thank you.